I saw a nice example of this when I was in India some years ago. I was in Khajuraho, India. It was really hot, like 110 Fahrenheit. And I was trudging through, and all these people were out in the field. They're all doing work out there, working in the field. In the corner of the field was a kid, a young kid, must be 8 years old or so. And that kid's job was to continually keep a great big clay pot of water cold. And how he did that is he had a gunny sack over the pot. The pot was open like this. He had a gunny sack over it, like burlap, yeah? And he had a little pot down here and a long stick with a gourd in there. And he would just keep making sure that the gunny sack stayed wet. And as long as he kept the gunny sack wet on that hot day, honeys, the water inside was begin with a C. And I ain't saying cool. Cold. H-C. Be checking your neighbor. See how that works, gang? See how that works? That gunny sack, water's evaporating, right? Which water? Which water molecules are evaporating? The fast or the slow? Fast. The fast. What's that leave behind? Slow. So the gunny sack then gets a little cooler than the outside. But the gunny sack is against the clay. And the gunny sack's a little cooler than the clay. Which way does energy go? From the clay pot to the gunny sack or the other way around? From the clay pot to the gunny sack. Heat flows from high temperature to low of itself, yeah? And so what happens, the gunny sack, the pot gives its energy to the gunny sack, and that keeps going off, off, off. You see what I'm saying? And so the pot gets cool, 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 but the pot's against the water inside. Now, if the pot's cooler than the water, and the pot's against the water, which way is the energy flow going to go, gang? From the water to the pot. And so you see, so long as he keeps having the fast-moving molecules leave on the outside, he's cooling the water on the inside. That's beautiful physics.